Okay, so let's do this trig problem that it was just in the lecture. So I went ahead and drawn the triangle that's in that example. We have a hypotenuse of 5 meters, an angle theta that's 37 degrees here. And we want to know what the opposite side of this angle is. And we want to know what the adjacent side is as well. So whenever we have a right triangle, we can immediately use our trigonometric functions, sine, cosine, and tangent. Now, so let's first work on this opposite side here. Okay? So if we know the hypotenuse, we can go back to our list of trigonometric functions, and we can pick one that works best. And of those trigonometric functions, the one that works best whenever we're dealing with the opposite side is the sine function. So remember that the sine of theta is the opposite side divided by the hypotenuse. Okay? So if we want to solve for if we know what the angle theta is, we know what h is. To solve for O, we need to multiply both sides by h. So let's multiply both sides of this equation by h, and we're left with O is h sine theta. Okay? Now, so we have an equation that we can eventually use here in a second to solve for O. Now, what about A? Well, if you go back to your list of trigonometric functions, the best equation to deal with the adjacent side is the cosine. Okay? Cosine of theta is the adjacent side divided by the hypotenuse. So if we multiply both sides of this by h, we're left with a very similar equation, but for the adjacent side. The adjacent side is h times cosine of theta. Okay, so now we can use these two equations and solve for O and then A. And this is something we'll be doing a lot, particularly early on this semester. Okay, so O is h times sine theta. H is 5 meters times the sine of 37. Okay, so if you go to your calculator here, the way this works is you just put in the number 37 and press sine. But you have to make sure that it's in degree mode. There are two modes on most calculators, degree mode and radian mode. Okay, we'll deal with radians a little bit later on this semester, but for now, you really want to have your calculator set to degree mode all the time. Okay? So when you do that for 37, get my calculator out right here. I do 37 sine, I get the number 0.6018. Okay? So that's the value of sine 37. You multiply it by 5, and you get the answer 3.01 meters. Okay? So there's the opposite length of this triangle. Same thing for the adjacent side. The adjacent side is h times cosine theta. So 5 meters for the hypotenuse times the cosine of 37. Okay, so you do 37 cosine on your calculator, making sure you're in degree mode again. Multiply it by 5. So 37 cosine is the number 0.7986. So we multiply that by 5, and we get the number 3.99 meters. Okay, so there's the adjacent length of that triangle. So we've solved the problem then. We've solved for the lengths of the opposite and adjacent sides of this triangle using our trigonometric functions. And I should add that the Pythagorean theorem we talked about still holds. Okay, remember the Pythagorean theorem? If we have a right triangle like this, okay, the sum of the squares of the legs of the right triangle equals the hypotenuse squared. Okay? So in other words, O squared plus A squared, which is in this case, the opposite side is 3.01 squared. Okay, I'm going to go ahead and maybe erase a little bit of this over here. Create some space. Plus the adjacent side squared, which is 3.99 squared. Well, when you do that, it equals what we had for the hypotenuse squared. And remember, the hypotenuse is 5 meters squared. Okay, so if you do that on your calculator, 3.01 squared plus 3.99 squared, you should get to within kind of the precision with which we're reporting these numbers, what you get when you get 5 squared, which is 25.